Okay, so today I'm going to be talking about error and percent error. The formula for error is the measured value minus the actual value. So what that means in terms of what we're going to be looking at is the measured value would be something like your data, the information you're collecting in your experiment, while the actual value is what you want or your goal. And for our first example, it says that Ms. Allgood asked 2 students to walk 500 feet, and they don't have a way to measure. Joe actually walks a distance of 506.3 feet, and Sally walks 497.4 feet. Calculate the error for each student. So I'll have one answer for Joe, and I'll do another problem for Sally. Our data, the stuff we collected in our experiment, is going to be the information that they actually went, what they found in their experiment. And then our actual value, our goal, was 500 feet. So to solve this problem for Joe, it's 506.3 feet minus the 500 feet. And that means that Joe's error was 6.3 feet. For Sally, it's 497.4 feet minus 500 feet, which gives us an error of negative 2.6 feet. That says that Sally was actually closer than Joe as far as her error goes. She was just below the mark, that's why she's negative, versus Joe, who was above the mark, which is why he's positive. So error tells us how far off we are, and it can be positive or negative. What we're going to be looking at more in this class is percent error. So percent error is the absolute value of your error, so that means you just make it positive, divided by the actual value, which is our goal, and then multiplied by 100 since it's a percent. So it asks us to calculate the percent error for each of our students. So again, I'll have one answer for Joe and another answer for Sally. So for Joe, my absolute value of my error is going to be what we found up here, so 6.3, divided by my actual value, which is what we want in this problem, which in this case is 500, times 100 because we want it to be in a percent. And if you do that math, you should get 1.26% for Joe. And then for Sally, it's the absolute value of negative 2.6 divided by 500 times 100, which means that Sally's percent error was 0.52%. Your percent error should never end up being a negative number because it's the absolute value. And then what that percent tells us is how far off we are. So a percentage that is close to 0 means you're very close to your targeted value, which is a good thing. If your percent error is a high number, then you want to try and figure out what your cause of error is and things like that. In terms of percent error, 1% is a very good margin of error. Anything greater than that, you want to take a look at what happened in that experiment. And then the last example, I asked the students to walk 17 feet. So that is what I want them to do. And then this girl named Mary walks a distance of 14.4. So it asks us to calculate the error and percent error. So to get my error, I'm going to take my measured value, which is what I got, my data, 14.4 feet. I always subtract, and then I go to my actual value, which is 17 feet. So Mary's error in this experiment was negative 2.6 feet. So that's actually the same as Sally in the first experiment. If I ask you to calculate your percent error, then you are going to take the absolute value, so that becomes 2.6, divided by the actual, which is what we wanted. That's, I asked them to walk 17 feet. And then you're going to multiply by 100. So we see in this one that our percent error was much greater at 15%. So here, if we take a look, our error was the same in these last two problems for Sally and Mary, except because our actual value was a much smaller number, it affected our percent error a lot more. So that's why we calculate percent error instead of error, is it gives us a better look at the problem.